Hello everyone. I'm just gonna record some of the contents that we've done last term, because as soon as I got the message of we're gonna go into lockdown, I've changed my plan. So on Tuesday's lesson, we've done something that we probably less familiar with. So I'd rather leave the things that you are familiar with for you to do at home. So I thought I'd just record a few short videos to recap the stuff that we learned from term 2, which is the specialized textbook 4A and 4B. And maybe even a bit more. We'll see how we go, okay? So 4A is the general tangent function. So we all know that tangent function is y is tangent x, but a more general form will be y equals to a tan bx take c plus d. All right. So, and we know that a is not 0 because otherwise it would not be a tangent function. Then we know b is above 0. Okay. So there are several concepts. Principal axes, okay? The principal axis will be y equals to d, because obviously that's the principal axis. And then we know how to calculate period, which is pi on b. Okay, so we all know that with the sine cos function is 2 pi on b, but with the tangent function is actually pi on b because the period is pi. Yeah, the period for tan x is pi. And we know the amplitude is undefined. Why is that? Okay, because I'd rather to see it with a graph. That's the tan graph. All right, so I've got here and here, so that's pi on 2. That's negative pi on 2. All right, or you could think as, so that's a tan graph. Okay, so it just keep that way. So that's 3 pi on 2. Okay, that's my pi. So tan x equals to sine x over cos x. All right, so at pi on 2, cos pi on 2 equals 0, so it's going to be undefined, and same way as cos negative pi on 2 is going to be undefined. So amplitude undefined, and there are, we're talking about asymptote, okay? So this is x equals to pi on 2. This is x equals to 3 pi on 2. So there are infinite many vertical asymptotes. Does that make sense? Okay. If we are talking about a unicircle point of view, all these, when cos equals to 0, will be the asymptote. Yeah. So that's going to be pi on 2 plus k pi. So x equals to pi on 2 plus k pi. Okay. So let's have a look at an example question of tangent. Okay. I'll write here. So from y equals to tangent x to y equals to 2 tangent x plus pi on 4, take 1. All right. So I want you to describe the translation. Okay. So first task is to describe translation. This is purely a revision from last term. Okay. Translation. Second, sketch graph. Okay, I'm really hoping you can pause this video a bit and then try to do it yourself. Okay, and then compare your answer with my answer. So first I'm gonna describe the translation. I'm gonna use another colored pen. So First one is that, again, I've mentioned before, each time with a translation, you always focus on x itself. Okay, so if there's a number in before, you got to factorize that before. Okay, so first step is the horizontal translation of pi on 4 unit to left. Second is I've done that. Okay, so this step will become y equals to 10x plus pi on 4. Okay, second step is the vertical dilation stretched. Make sure you got these, okay, because otherwise, if you only say dilation, people don't know what is stretch or shrink. Okay, stretched with a factor of 2. Okay, so that will become, remember, all the translations are based on the previous step. Okay, if my previous step I have these, then another dilation will become 2 10x plus pi on 4. Okay, last step is a vertical translation. All right. Oh, yellow. All right. Vertical translation. 1 unit down. Okay. So that will become 2 10x plus pi on 4. Take 1. Well, a lot of you still make errors with the sequence of how you describe a translation. If you want to describe the vertical translation first, okay, so now there's a problem will be involved here. If you do want to describe the vertical translation, all right, then you still can, but what you need to do is you need to factorize it, okay? So if you, okay, I'll write down here. So the first one is still a horizontal translation, become y is 10x. So I'm just gonna draw an arrow here, okay? So x plus pi on 4, okay? So the second one, if you want to describe a vertical translation, you will need to do another step here. So y equals to 2 10x plus pi on 4. Take half, all right? So you got to do vertical translation 1 on 2 down. That will become y equals to 10x plus pi on 4. Take half, okay? And the last one will be the dilation, okay? So it's going to be a vertical dilation. Okay, so it's gonna be, because it's half, no, sorry, yeah, it's still gonna be stretched, okay, stretched with a factor of 2, okay? Because when you times the 2 with the above function, okay, I'm gonna change another color here. When you times 2 with the above function, that's gonna be y equals to 2 10x plus pi on 4. Take away half times 2, 1. So you end up with the original function. Make sense? Okay. So that's how you describe the translation. Okay. Okay. I'm just gonna sketch the graph to give you an idea of how to sketch this graph without a calculator. You can use a calculator to check, but I don't suggest you to use a calculator to start with, okay? Because understanding how the translation works will be better for you. So based on these 3 transformation, okay? So first, so I know original 10 function, okay? So my 10 of x will be these, all right? I'm just gonna draw it, pi on 2. Negative pi on 2, okay? So I've got a origin 0, okay? So imagine this point is gonna be it's going to be translated of pi on 4 to the left. Okay, imagine that's pi on 4. Okay, and then dilation, I won't be able to show dilation in a point, and then it's going to be translated 1 unit down. Okay, so the previous origin has become here. Does that make sense? Okay, and also my function is this one. Again, as we mentioned earlier, the principal axis has become -1. So that's my principal axis. So tangent x has a principal axis of y equals 0, but this one has a principal of axis of -1, y equals to -1. Okay, so my previous origin point has moved down to here. Okay, and this is negative pi on 4. I'm just going to write down here, negative pi on 4 here. Okay, so you can see there is a shift like that. Yeah, and my period is pi on 1, which hasn't changed. Okay, so the period didn't change. So imagine all the point, this whole graph is moving pi on 4 here and 1 down. Does that make sense? Okay, so you kind of end up with a graph like this. Yeah. So now my question is, what is the y-intercept? Okay, what is the y-intercept? How are you going to calculate the y-intercept? By substitute x equals 0. So the y-intercept, which is you need to know how to calculate, x equals 0, y equals to 2 tangent 0 plus pi on 4, tan pi on 4, take 1. So which is 2 tangent pi on 4 is 1, take 1 is 1. So that's my y-intercept, which is 1. Okay? And that is my asymptote. How would you calculate an asymptote? Okay, so imagine, this is a horrible drawing because it's not, yeah, so you can see the 1 is not, yeah, but that's 1. Okay, so, and then all the other points shift. All the other points are shift based on that transformation. Okay. Okay. Now, to answer my question, where is the asymptote? Because my period hasn't changed, so I've got negative pi on 4, so half of tangent is pi on 2. So if I've got negative pi on 4, this would be pi on 4, because 2 pi on 4 will be pi on 2. Okay, so this asymptote